Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today, inshallah, we'll do one example for optimization. Just that since we are not going to have any online class, so I'm thinking of doing an example with another example with all of you. So let me just share the my screen. Okay, so this is a question. This is a final exam question taken from semester 1, 2019-2020. So basically, this is from last semester. The exam was on 15th of January 2020. Let me just go straight away to part B, question 4A. Okay, so focus on question 4A. We have an optimization problem here. So the question says that suppose the average cost of a mining operation depend on the number of machines used, and the average cost in dollars are given by this function C bar X equals 13X plus 8,788 divided by X, where X is the number of machines used. So logically, X must be greater than 0. Okay, must be non-negative. How many machines that would give minimum average cost? So 8 marks. So let's try to do this question together. So we have an average. Oops, sorry, should change this to a pencil. Okay, so we have an average cost C bar X. Okay, where X is the number of machines and it is 13X plus 8,788 divided by X. Okay, so we need to basically minimize the average cost. So what is this? This would be the average cost, and X is number of machine. So step number 1, we need to basically, so this information is already given to us. So there's not many things that we need to do because unlike in the examples where we are given separate information with regard to the price or demand, where we need to come up with the revenue function, in this question, the equation is given straightforward. So we simply need to minimize C bar of X equals 13X plus, okay, I'm just going to bring this up just because to make the differentiation easier. Okay. So from the denominator, it will be to the power of -1, this X. Now, step number 2, we need to then find the critical numbers. Okay, so what are the critical numbers? So critical numbers, basically, we need to find the first derivative and set it to equal to 0. So from here, what is our C prime bar of X? It would be 13. And then we have negative here. So minus 8,888 X to the power of -2. Okay, and we're gonna set this. So this is basically 8 by X square, and we set it to equal to 0. And then we can solve this. So how do we solve this? So we have 13 equals to divided by X square, and this is gonna give us 13X square equals 8,008, and we're gonna have X square equals 8,788 divided by 13, which is, we have, just put my calculator on this side. So 8,788 divided by 13 equals 676. And so X equals the square root of 676, which is, what is my square root? 26, positive 26. Positive 26. So we simply ignore negative 26, the other root, because X has been stated it has to be positive. Okay, it has to be positive. And now step number 3, we need to investigate, we need to use the second derivative test to identify the nature of this critical point. Okay, so second derivative test to check whether this critical number, is it a minimum or a maximum. Okay, so to do this, we need to find the second derivative. So what is the second derivative? Now the second derivative would be, now 13, there is no x here, so 0 for the first term, minus. So here we have x to the power of negative 2. So I'm going to bring negative 2 to the front, and I'm going to have 8788, and my x now would be to the power of negative 3. Okay, so this would then equal, so negative, negative, positive 2. So I have 2 multiplied with 8000. 8 divided by x to the power of 3. And this would give me, so what is 2 multiplied with 8788? Calculator, 8788 multiplied by 2, which is 17576. So I'm going to have 17576 divided by x to the power of 3. Now we have to we need to evaluate the second derivative when x equals to 26. Now, as you can see, we don't even have to plug in this 26 inside here because this is already a positive number. Okay, a positive number. So we know that this is greater than 0. When it is greater than 0, it is positive. So we have a smiling face, right? So smiling face, this is concave upward. And it is a, so this is a minimum. Okay, this is a minimum. So this brings us to the final answer, that such that, so to answer the question, so we have 26 machines, right? 26 machine, this is our, the answer is 26, right? From the critical number that we have found here, 26. Okay, 26 machines give the minimum average cost, okay, which is, although it is not stated in the question, but sometimes the examiner may ask you to give which the what is the minimum average cost then. So what you need to do is you simply need to replace x equals 26 in the original function. So we have 13 multiplied by 26 plus 8788 divided by 26. So 13 multiplied by 26, which will give us, so what is 13? I'll put it here. 13 multiplied with 26, which is 338. So 338 plus, have 8788 divided by 26, which is 338 as well. So 338 plus 338 would give us 767. So this is the minimum $676 would be the minimum average cost when we use 26 machines. And that's basically the, where is my, oh, here, presenting. So that's the, to show you the steps how to answer a question on optimization. And if you you know, if you have enough, I think, training and exercise, you see, I mean, how quickly we were able to solve the question. So it would be a, I think you should put that as among the easy questions where you can get you can score well to get the full mark. It is not that difficult. It should be easy once you get used to the steps, and you need to just be careful in doing your calculation. So that's all for now. We'll see again next time, inshallah. Assalamualaikum warahmatullahi wabarakatuh.